Okay, good afternoon, dear students. Today we will solve some important questions which are asked by some student to me. One question is the limit x tends to 0, e to the power 1 upon x minus 1, e to the power 1 upon x plus 1. In this question, first we should know that the graph of e to the power x, and this is the graph of e to the power x. This is the negative side of x and this is the positive side of x, y-axis, and this is the graph of e to the power x. When x tends to infinity, then the graph tends to e to the power, when x, it's mean when the graph of e to the power x is when x tends to infinity, then e to the power x tends to infinity, and when x tends to minus infinity, then e to the power x tends to 0. Okay, this is the basic condition for e to the power x, graph of e to the power x. In this question, the question is the find the limit of the function at x tends to infinity. Then when we take a right hand limit, then x tends to 0 positive, right? It's mean when x 1 upon x tends to, this implies 1 upon x tends to infinite, and this is implies e to the power 1 upon x tends to, when x tends to infinite, when this value tends to infinite, then e to the power x tends to infinite. Okay, and this is implies 1 upon e to the power 1 upon x tends to 0. Okay, so we can convert this question, limit x tends to 0 positive. We can take common from numerator 1 upon x and 1 minus 1 upon e to the power 1 upon x, and in denominator we have e to the power 1 upon x, 1 plus 1 upon e to the power 1 upon x. Okay, after cancel out this, when x tends to 0 positive, this value tends to 0, and this value tends to 0, 1 upon x and 1 upon x tends to 0, 1 upon e to the power x tends to okay, and this value tends to 1 upon e to the power 1 upon x tends to 0. It's mean when we x tends to 0 positive, then this value tends to 0 and this value tends to 0. It is equal to 1 upon 1, and this limit tends to 1. Okay, positive limit tends to 1. Similarly, for the negative case, uh, it's the right hand limit tends to, the right hand limit of this question tends to 1. When x tends to, for the negative value, when we take the left hand limit, it means x tends to 0 negative, and 1 upon x tends to minus infinity, 0 negative minus infinity, and e to the power minus e to the power 1 upon x, e to the power minus infinity. Okay, we can write it e to the power minus infinity, e to the power 1 upon x, e to the power minus infinity, and it is equal to 1 upon e to the power infinity, and it is equal to, we know that e to the power infinity equal to, when we take the infinity, the graph is infinity, e to the power infinite equal to infinite, e to the power infinite equal to infinite, 1 upon infinite, and this is equal to 0. It's mean the when we 1 upon x tends to minus infinity, then the e to the power 1 upon x tends to 0, right? So the in case of the left hand limit of this graph, left hand limit, limit x tends to 0 negative, e to the power 1 upon x minus 1 upon e to the power 1 upon x plus 1. Okay, e to the power 1 upon x equal to 0, then this value is 0 and this is also 0. In numerator we have minus 1 and in denominator plus 1. This is equal to minus 1. Okay, so the left hand limit of this function is minus 1 and right hand limit of this function is 1. In this case, the left hand limit does not equal to the right hand limit. Left hand limit not equal to right hand limit and the limit of the function does not exist. Okay, and similarly if we have this function, suppose that this is a function fx, and at x it tends to 0, this function is discontinuous and also the limit does not exist for this function. Okay, and this is the first kind of discontinuity of the function, or we can say that the limit does not exist for this function. Thank you.